Hello. I want to work through section 5.7 today. 5.7 looks at how we make solutions for doing labs. Now when we're making a solution, remember we said yesterday that we make solutions that have got a certain number of moles in a certain volume. And when we do that, we can know how strong the solution is or how concentrated it is. And in our lab from yesterday, we said the concentration is determined by taking the number of moles that we are going to dissolve and the final volume that we're going to get. So if I took a beaker and I put in so many grams of my dry chemical, and then I added water, right, and then the powder dissolved at the bottom here, right, and now it's dissolved in the solution here. I have a certain number of moles in my volume. I know how much powder I added or how many grams, and using my N equals M divided by molar mass, I can calculate the number of moles that I put in my beaker. Then I know how much volume there is because it actually says on my beaker, this is the, 200 milliliter mark. Now, it's not very accurate. There's much better ways to get 200 milliliters, but that would give you an idea. And then if I know how many moles I've got and what volume I've got, I can now use that to determine the concentration. Right? Brings me back to this formula over here. Now, whenever we're doing labs, before you ever show up to do the lab, I always come in the night before and I make the solutions up by dissolving in Erlenmeyer flasks. Usually there's an Erlenmeyer flask. I will put my powder in the bottom here. Let's say it's sodium chloride. I will figure out how many grams of sodium chloride I need by determining how many moles I need. And then I'll figure out how much water I'm going to add to the solution. And then the powder will dissolve. And now I have my solution here. This will be solution A. And then I'll come in and I will make my second solution in an Erlenmeyer flask, and I'll put my dry powder at the bottom, maybe it's silver nitrate, and I will add my water, and then the silver nitrate will dissolve. And now I have my second solution. So if A is sodium chloride and B is silver nitrate, my products will be double displacement. The sodium will replace the silver, so I will get sodium nitrate and silver chloride. Now, for this to work, it's balanced already, right? It just turns out that this chemical reaction is already balanced. And what that tells me is that, let's get rid of this, and get rid of this. What that tells me is that 1 mole of this reacts with 1 mole of this to make 1 mole of this and 1 mole of this. Now, if I have 0.2 moles of this, I will need 0.2 moles of this, and I will make 0.2 moles of this and 0.2 moles of this. What I do need to know, right, is that the amount of this is equal to the amount of this, right, the number of moles. Now, to determine the number of moles, if I go back up to my formula, up here, I can rearrange this formula and I can take the volume from here up to this side. If I multiply both sides by V, these V's cancel, and I end up with N equals C times V. Okay, same formula that we were just using, except I've rearranged it now. So to calculate my number of moles, N, and the same thing here, to calculate the number of moles. So if I know what concentration my solution is, I can figure out what volume I need to get that number of moles. If I know the concentration of my silver nitrate solution, I can figure out what volume I need to get my right number of moles. So the critical piece right here is to make sure that I have solutions made that have the right concentration, right? The right strength of solutions. So that's what this next section is about today. It's about making up those solutions, right, that we need to do a lab. So it says in the note here for 5.7 that we often need a solution for a lab that has an exact concentration of solute. Okay, I need to have the right concentration. And now I need to, before I start the lab, I have to make that solution. Now to make the solution, I need to know a couple of things. I need to know the concentration, right? And to determine the concentration, I need to know what volume I need and or the number of moles. The amount of solute, which is N, the number of moles. So N is the number of moles, V is the volume, and C is the concentration. So I'm back to the formula that I have down here, right? C equals N divided by V. Okay, that was our formula from yesterday. Right, when we were talking about determining molar concentration. Now, what we're going to do in the lab is I will often tell you, when you're doing the lab today, go and get, so let me just erase some of this stuff. I might say to you, go to the bench at the back of the room and look at beaker A or flask A, and I want you to go to that flask and I want you to take 50 milliliters of the liquid out of that flask. Right? And what you're going to do is you're going to take the graduated cylinder. Graduated cylinder goes up to 100 at the top. 90, 80, 70, 60, 50, 40, 30, 20, 10. There's 50. And I'm going to pour my liquid from here into here. And I'm going to have my 50 milliliters of liquid. And if I know the concentration, I can calculate the number of moles of NaCl. Right, so again, remember the goal here is to be able to make this solution here and this solution here. Now, if I know that you need 50 milliliters, and that the next group needs 50 milliliters, and the next group needs 50 milliliters, I can say, how many groups are in the class? Well, there's 10 groups. So there's 10 groups, and everyone needs 50 milliliters. I need 500 milliliters. But you know what? Someone might spill some, so I'm going to make some extra. I'm going to make 600 milliliters is how much I'm going to make. So I now know what volume that I need, and I know what concentration I need because the textbook told me you need 0.100 moles per liter, or 0.25 moles per liter, or 1.4 moles per liter. We're often told the concentration, and we're told the volume that we need. So before we come to doing our lab now, right, I'll often need to know the amount or volume, the volume of solution that I'm going to make, and the concentration. Now, if I know V and I know C, okay, let's go down to here. If I know V and C, I can solve for N. N is equal to C times V. I'm just going to rearrange that equation, right, by bringing the V from the denominator here up beside the C, and I get N equals CV. So now I can calculate the number. Now I can calculate the number of moles that I need, and to determine the number of moles, that's one thing, but then I also need, I can't measure moles on a scale, on a balance, I actually need to measure the mass. So I'm going to take my little n here, the number of moles, little n, the number of moles, and I'm going to convert it to the mass that I need in order to do this lab. So that's what we're doing in today's note, is we're looking at how do I make these solutions. Now, the easiest way to do this is for me to show you with a couple of sample problems. So there's a couple in the textbook that they've done, and I'm just going to go ahead and do the questions from the textbook, and then I'll leave you with a couple to practice. Okay, so this is how I make a solution. Now, it says calculate the number of moles of KMnO4 potassium permanganate that is needed to make 250 milliliters of a solution that is 0.1 moles per liter. Okay, so there's the question. Calculate the number of moles. So I'm going to have to go to my other page here. So I know the concentration is 0.1. I know the volume is 250 milliliters. Okay, so let's go to my whiteboard here, and let's just clear it. And let's start with the sample 8. On page 191. Now again, this is the same sample problem that they've done. So as I read through the question, we're told a couple of things. So what are we given? I'm given the volume of liquid that I'm supposed to, of solution that I'm supposed to make, 250.0 milliliters. Now if you remember when we were doing our molar concentrations, our volume was always in liters. So I'm going to have to, before I do anything, convert this into liters. I know that 1 liter is the same as 1,000 milliliters, and my milliliters cancel, and all I'm doing is taking the 250 from here and dividing it by 1,000 times 1 divided by 1,000, and I get 0.2500 liters. Notice I had 4 significant digits here, so I'm going to have 4 significant digits here. We're also told in the question the concentration of the solution that we're making is 0.100 moles per liter. Okay, 0.100 moles per liter. And what I'm required to find is how would you make 250 milliliters using an electronic balance and a bottle of crystals of KMnO4, potassium permanganate. We're actually told in the question the molar mass of KMnO4, but we'll do the molar mass ourselves. So the required here is how do I make this solution? Well, I'm telling you how I'm going to make it. I'm going to weigh out my crystals. I'm going to put them into my flask here. I'm going to add my water, and I'm going to watch the crystals dissolve, and then I'm done. So that's what I'm going to do. But what I need to know is how much water. Well, they told me that in the question, 250 milliliters. And I need to know how much powder, KMnO4, I need to add. So let's go down here. My required to find here is how much KMnO4 do I need to add. Now, my approach, right, to solve for mass, I need to know the number of moles, right? So mass is equal to number of moles times molar mass. I can calculate my molar mass is KMnO4. KMnO4. So my molar mass contains 1 potassium. Potassium is 39.10 grams per mole, plus manganese. Manganese is 54.94, plus 4 oxygens. 4 times 16.00. When I do all the math, I should come up with 158.04 grams per mole. Remember, it's big M, it is molar mass. So, to calculate mass here, I need to know number of moles and molar mass. Well, I know the molar mass now, right, because it's right here. But I don't know little n yet. So the question is, how do I figure out n given the information in the question? Well, the question told me C and V. So if I look back at my formulas, it's right here, C is equal to N over V, or N equals CV. So there's my formula. Again, it's at the bottom of your periodic table. So N is equal to concentration times volume. Now, remember, I'm trying to find N because I need N to put in here. Right? I already know this. If I know little n, I can solve my question. So my C was given in the question. It is 0.100 moles per liter. And the V is the volume, which we said is 0.2500 liters. Notice that the liters in the denominator and the numerator cancel, and I'm left with 0.0250 moles. Okay, so now I know N. Right? I can go back to my original formula up here, and I can solve for mass. So, to solve for this now, okay, so that's all part of my approach. To solve for this, mass is equal to the number of moles times the molar mass. The number of moles is here, 0.0250 moles. Right, that's right there. Times the molar mass. Molar mass is 158.04 grams per mole. That's the number from here that we calculated from the periodic table. And I end up with 3.95 grams. Okay, so the question was, how do we make this solution now? I'm going to take 3.95 grams. So this is my final answer here. My phrase, my therefore statement, or by phrase, therefore, I need to dissolve 3.95 grams of KMnO4 in 250 milliliters of water. Okay, and that's how I'm going to make this solution. Now, I think it looked like there might have been a B part of that question. Okay, so they've done it in two steps. Calculate the number of moles, then calculate the mass. Okay, so that's how we're going to do this question, right? To determine, again, just keep looking at the formulas that we have at our availability, on our formula sheet. Okay, so again, let's go back one more time now. So I now have, I can go from mass to number of moles, from number of moles to number of particles. To go from M to N, I know mass is equal to the number of moles times molar mass. So to make this formula work, I need to know molar mass. To go from big N to little n, I know that big N is equal to little n times Avogadro's number. And to make that formula work, I need to know Avogadro's number. But I do know Avogadro's number, right? 6.02 times 10 to the power of 23. And now we have one more formula to add to our collection here, and it says C is equal to N divided by V. So I now have three equations to use in Chapter 5. Right? Those are my three equations right there. So depending what it's asking for, concentration, or mass, or number of moles, or number of particles, we can switch between these given the information that's in our question. So I'm going to stop there for today, and I'm going to leave you with 2 of these to try. I'm going to suggest you read the question, the sample on page 191. It's the one I just did. Okay, read it for yourself, because they've got some good graphics, and I think they talk you through the question very well. Right, so read through that sample question on page 191, and then do these 2 practice questions. These 2 practice problems on page 191.